If you don't have enough water, you're going to dehydrate the body and you're going to die. So you need to hydrate the body with bioavailable water. That means it has to have a negative ionic charge and it has to be alkaline to help neutralize all the acids that we're consuming.
May I introduce you to a great water that brought me back to life?
It's just a little concentrate. You put it in water, you drink it, and there you go. So when you do real water concentrate, put that into water and shift it to alkaline, create a negative ionic charge, you start opening up those little ports in the cell. Now water's getting in to hydrate. When water goes in, it hydrates, but it's also a universal solvent. It pulls the waste and toxins out. This is stabilized, alkaline, negative ionic water. I've been in natural healing for 37 years. I've been a researcher. I've been looking for something that will do this simple.
And coming up, the unmasking of bottled waters. Consumers react to word that many of their pricey favorites come straight from the tap.
People pay extra for bottled because they think it's better. Better tasting, better for you, certainly better than tap. But is it?
You've heard of alkaline batteries, but what about alkaline water?
Hi, my name is Brent Jones, and I'm president of Real Water. We're the owners of the E2 technology, which stands for Electron Energized. I'm really excited today. We're going to explain our product. It's called Real Water. And we have two types of Real Water. First, we have the ready-to-drink bottles, which are over here, and we have a concentrate, which you can take a good purified water and actually change it into real water. Here's the situation. Most water we drink today has two major problems with it. One, it's acidic. And two, it is very positive ionized, which means it has a positive charge. It's basically a free radical. It wants to steal electrons. Our water is just the opposite. It's alkalized, and it is an antioxidant. It's negative charged. It wants to donate electrons.
What we're talking about here is we're talking about a water that will donate these electrons, making the water a negative ionic charge, which in essence is a free radical scavenger, which we would call an antioxidant. So we need antioxidants because we live in an acidic environment. We live with free radicals. We've all heard about free radicals. And free radicals not only contribute to known diseases, but it's a major contributor to premature aging. So when someone says, you know, I'm looking older than I used to, we're talking about free radical damage, and it's really technically called oxidative decomposition. This real water concentrate, the real water, with the technology that you have talked about, will shift the pH to alkaline, create a negative ionic charge, which makes it an antioxidant, and this is exactly what people need.
Now, what I want to show you is the power, or show you existing bottles of water and how they are compared to the real water. The first bottle I'd like to show you is a very well-known bottle of water, and it's in the natural products community. And we will go ahead and open it up, just popped, pour some in here. Now we talked about two things. We talked about the charge, and we talked about the alkalinity or acid. I'm going to go ahead and take this off. Here we go. Now, I'd like to show with this meter right here, if we can move our concentrate over a little bit. Do you see the positive charge on the meter that this water has right now? Very positive. which means it's been stripped of electrons and it actually has a strong positive charge.
I should point out, this is an ORP meter. This is oxidation reduction potential. So this is doing exactly that. It's going to register whether you have a positive charge solution or substance or a negative charge. And what do you have here? You have about 540 on the positive side. So this is actually promoting free radicals.
Let's look at the acid versus the alkaline. Okay, so we poured a little bit in here, and what I have, this is a standard pH testing solution. And you can get this at a hydroponic store, anywhere where you need to be able to test what the pH of a solution is.
The pH stands for potential hydrogen. And the scale on pH is 1 to 14. Some people say it's 0 to 14. 7 indicates neutral. So if this registers as a 7, which would be right here, that's a neutral pH. If it's below 7, this is an acid pH, and if it's above 7, it's an alkaline pH.
And also, the lower the acid, the stronger the acid. Like a 1 will burn a hole through your table.
Absolutely.
And then the higher the pH, the more strong it is in alkaline. And you know, whereabout is our body's blood, Dr. Spell?
The body's, the blood pH is 7.356 to 7.456.
So just a slight alkalinity.
Little alkaline, yeah.
Okay, so...
But I should say this, it's significant to be that alkaline, because if you go below that range or above that range, you can actually die. The body at all costs will maintain the blood, and I always say 7.35 to 7.45. That's the range that the body will strive to keep the blood.
Okay, so we're going to go ahead and look at this bottle right here, and here is the pH. I'm going to go ahead and put a couple drops in this solution right now. Give it a little shake.
There you go.
Voila. That is a nice, I don't know, about a 4 acid right now. So
that's acidic.
Very acidic.
Yeah, that's right.
So this water you're drinking is positive charged, plus 500, free radical, which again here we'll show you, plus 500 and something, and acidic. Watch the meter when I add our real water concentrate into that little glass. Ready? Did you see that? It just went negative.
Okay, now you can see the negative mark right here, and it's a negative 40, no, it's now 411 and climbing.
So what we basically just did was added, well, billions and trillions, quadrillions of electrons.
Of electrons that have made this solution now a negative ionic charge. And the significance there, this is what's really important, the significance there is that when you have a positive charged water, the molecules of water will clump. And it makes it difficult for a cell membrane to pull that water molecule through if it's clumped like a bunch of grapes.
Right.
But when you have a negative charged water, it separates the molecules. They're no longer trying to share electrons. They have their own electron. And now you have a molecule of water easily going through the cell. So what we're talking about is real hydration. We're talking about bioavailable water, water that's truly hydrating.
Now, here's the magic. Watch what happens with the pH. Same water with the real water concentrate.
My, look at that.
Now it's a nice 8-9 pH.
Yeah.
So you just took that 3 acid or 4 acid and turned it into 8-9 alkalinity. Yeah. Amazing.
There's a real easy connecting link here. If you are acidic, the body has to keep the blood 7.35 to 7.45. In order to do that, it has to buffer the acids. What does the body use to buffer acids? Minerals, specifically calcium. So it'll pull calcium from the bones, from the teeth, to buffer acids. Like I have said before, just one soda, just one 8-ounce can of soda, it will take 32 8-ounce glasses of water at a 10-point pH to neutralize that soda. If you don't neutralize it using something like real water concentrate, the body will neutralize the acids for you by simply pulling calcium out of the bones and teeth. Out of the bones is called osteoporosis.
Okay, here's another one. In fact, this is one of the most popular bottled waters on the market right now. It and another comprise about 40% of the bottled water market. Just popped open. Heard that? Pour some in.
Now, what we're testing with the meter, again, is the ORP, oxidation reduction potential. We want to know, does this have a negative ionic charge or a positive ionic charge? It's climbing. Now, this particular water may not have the same level of positive ionic charge as the other water. We're at 265 now. It may hit 300, may hit 400.
Yeah, this water usually gets around 300, between high 2s to 300. So while we're watching that meter, let's go ahead and check the pH on it also.
Remember, we want, ideally, we want a little on the alkaline side, and even as much as 9.5 is good.
Okay, this isn't as acidic. It's actually probably moving up almost between the 5 and the 6. So compared to the previous one, it's a little bit better.
So we have an acid pH, positive ionic charge. Let's see what happens to this water when you put the real water concentrate in there.
Okay, so right now we're around a little over 300.
We're about 300, well, it's not really stabilizing. I'd say about 300.
Okay, here we go again with the real water concentrate. Watching it.
Yep. Let's see. Well, immediately we're at a minus 450, minus 460. So now we've taken that positive ionic charged water and immediately with a half eyedropper, you've brought it into a negative charge, and not just a negative 1 or a negative 2. You're at a negative 472 right now.
And I would like to know, you mentioned half eyedropper. That's about a milliliter.
Yep.
Normally a milliliter we'd add to 8 ounces, where this is probably about 3 ounces.
Right. So you're getting a stronger reaction.
Some of you might be wondering, that's good. We see the concentrate work. Let's see the actual bottled water.
Okay.
So while we're here, we'll go ahead and we'll take one of our bottled waters. And here is a bottled water that you can get at fine retail establishments throughout the country. And we're going to go ahead and crack the lid, so listen for that. It's a fresh lid. There it goes. Okay, well, ready to watch that meter.
There we are. We have a minus 360 and climbing. We're definitely into the negative ionic charge here, 362 now.
And we'll check that.
Coming right from the bottled water without adding the real water concentrate, because real water concentrate is in there already.
Yes, it's ready to drink.
Yeah.
So now let's check the pH. And again,
right in between.
Right there.
Yeah.
8.9 pH.
What people need to understand is that it's just not water that's going into that cell. When the water goes into the cell, it's going to pull nutrients in with it. As the water gets into the cell, it's going to take the cell metabolic waste products and pull it out.
Push it back out.
So you need water that'll get in. You need with the nutrients. You need the waste to come out, and that's part of the bioavailability of water. When you have clumping water, when you have a positive ionic charge, when you have an acid pH, that process isn't working. It isn't working to zero. It's just not working very effectively. I mean, if people might drink 8 ounces of water, and maybe they're actually making 1 ounce or less bioavailable. They're getting some water, but they're not getting the proper hydration, and they're not getting the nutrition. That's why I've said for 37 years, we're a nation that's overfed and undernourished. We're eating like crazy, but we're not getting the nutrients because we don't understand that hydration is actually the first plank.
Right.
You have to be hydrated in order to pull in nutrients and remove waste.